Hey guys, it's Miss Rainey again. We're going to work a couple of more homework problems. This time we're looking at the Neutralize It homework. I'm not going to do every single one of the problems, just a couple here or there to help you with the things I think might be the most confusing. Are y'all ready to go? Okay, let's go. The first problem I have for you today is number 4 from your worksheet. It says a titration is performed using KOH as your base and HCl as your acid. 35 milliliters of 0.5 m KOH are required for each of the 3 trials. The quantities of HCl used for the neutralization were 15.5 milliliters, 15.4 milliliters, and 15.7 milliliters. Calculate the average molarity of the solution. So, in this case, we've got a burette, and we've got an Erlenmeyer flask. Pretend like those are lined up. And in the burette, we have acid, that's HCl. And the first thing we're going to do is put that HCl into your flask. And it's going to take us 15.5 milliliters. Then we're going to take that to a different burette, same Erlenmeyer flask, that has the acid in it already. But then the next burette is going to have KOH in it. And we're going to put some KOH in there as we go. And it's going to take, 35 milliliters of the KOH and 15.5 milliliters of the HCl. And then eventually it's going to turn red. It's going to turn red because I put in enough base and I got it to my equivalence point. So for this trial, I only used 15.5 milliliters of my acid. But then I'm going to do it again, and my second trial, I'm going to need 15.4 milliliters. And my third trial, I'm going to use 15.7 milliliters. And every single time, I'm going to use 35 milliliters of my base. So if I want to find the average molarity, and the base is always 0.5 m, then it seems like the best thing to do would be to take the average of all of these milliliters. So 15.5 plus 15.4 plus 15.7 is equal to 46.6 milliliters. Divided by 3, because there were 3 trials, is equal to 15.53 milliliters. That's my average volume of my HCl. So that is my VA. From there, it's a simple matter of MAVA equals MBVB. So the molarity of my acid is what I'm looking for. The volume of my acid is 15.53 milliliters, the average volume. Molarity of my base is 0.50 m. Volume of my base is 35 milliliters. Divide both sides by 15.53 milliliters. So that my milliliters cancel on one side and everything cancels on the other, and X is equal to 1.13 molar as an average. There you go. Okay, the next problem we're going to work is number 9 on the back. It's one of the true-false problems. Actually, all the rest we're going to do are true-false problems. So these are true or false, and we're going to talk about which one they are and why. So for number 9, if you miss the end point by adding too much base, you must start over. Okay, well, first of all, you must start over. Hardly anything in life is guaranteed. So that on its own probably makes this a false statement. But you don't have to start over, because you could do a thing called back titrating. And so let's say you've poured in so much base and it turned pink and it didn't go back. So you could go back to the acid and add some more acid until it turned clear again, and then go back to the base and add it slowly this time until it goes just back clear. That's called back titrating. So you don't have to actually dump out your stuff and start over again. You could just go back, put more acid in, and then put some more base in. Number 10, if 10 milliliters of KOH are needed to neutralize 35 milliliters of HCl, then the base is more concentrated than the acid. So what we're saying is we need less base and more acid. But remember, the moles of base have to equal the moles of acid. So if I'm using less of the base, then the base has to be more concentrated. Less base, more concentrated. And then if I'm using more of the acid has to be less concentrated, because one goes up, the other goes down. They're inversely related. So if 10 milliliters or KOH are needed, then the base is more concentrated. That is a true statement. Okay, look down at number 12. Never forget to add 3 drops of phenolphthalein to the burette before titrating. So never forget to add 3 drops of phenolphthalein is a true statement. Even though it's an absolute never forget, it's actually a true statement. But this is false, because it says to add the phenolphthalein to the burette, which is not true. You should be adding the phenolphthalein to the Erlenmeyer flask, not the burette itself. So it would have been true if it said, never forget to add 3 drops of phenolphthalein to the flask before titrating. But what makes it false is the burette statement. Okay, I have 2 more I want you to look at. Number 17, 0.001 MHNO3 is more concentrated than 0.1 MHNO3. So the concentrated is the molarity. So 0.001 and 0.10. This is more concentrated because it's a higher number, which means that this statement is false. Okay, number 20. Before filling your burette with base, rinse the burette with some acid solution. Okay, that doesn't even make sense. So that's going to be a no. Before filling your burette with base, rinse the burette with some base solution if you want that to be a true statement. Or rinse the burette with water, but then rinse the burette with base. Or put some base in there and then let the base kind of run through a little bit and then fill it up all the way with base. Don't put acid in there because that acid's going to neutralize the base before it hits your flask. So that would be a bad idea. Okay, so those are the only problems I'm going to work here for you together. You are in charge of all of the other problems on this paper. So good luck, and if you have any questions, please let me know. Okay, bye guys.